All right. So today I'm going to demonstrate a login CSRF against an OAuth 2.0 flow and what happens when a client's callback endpoint forgets to validate the state parameter. And of course, RFC 6749, which is basically the OAuth 2.0 updated guidebook and guideline, section 10.12 calls state out specifically as a CSRF countermeasure. So this demo is going to be a case of removing this documented safeguard. And here's the plan. I'm going to be hand coding two things. First, a deliberate vulnerability in my own auth server that leaks a raw auth code into the page instead of redirecting with it. And secondly, I'm going to make a phishing page that takes the code I've obtained for my own account and tricks a victim's browser into submitting it to the client's callback, logging that victim into the hacker, which is going to be me this time's account, instead of theirs. So I'm going to run the whole attack end to end. I'm going to be live coding, and I'm going to be explaining my thought process and explaining step by step what is going on with the hack shown later on. All right, so let's start with the server change. I've got my workspace ready of the safe and correct implementation, all according to RFC 6749 standards. And we'll take a look at our auth server here. We want to find authorize.js because this is where all the authorizing logic goes on. And this is where the state parameter is going to be held. So if I scroll down, yep, here it is. Line 383 says, after checking for the state and setting the state, it returns a redirect of the redirect URI and the parameters and the parameters of the code and state. That's what I meant. And this is the correct implementation. This is correct. The code doesn't go anywhere that a human can read it because it travels in one automatic leap from browser to browser. Because a HTTP redirect is going straight back to the client's registered redirect URI here with the code and state attached as query parameters. I'm about to break this. And before we do that, let's check out to our exploit branch, which is currently the exact same as a main branch for the SRC. But we want to do our exploiting here so our main and safely implemented branch is untouched. Let's actually just fully delete 383, or let's just comment it out for comparison. And we start from here. All right, so first of all, let's go with res send, and yes, send. We're changing res send instead of res.redirect because this is the root of the whole vulnerability. I'm swapping an automatic browser redirect for a page that the server actually renders and stops on. The moment we do this, whatever we put into that page becomes something a human reads and can act on, instead of something that flows through invisibility. So this is an attack vector already cooking. All right, and then of course, let's make a header. It doesn't do the automatic header completion, so we'll do that. And we'll just do something like authorization successful. And yeah, this is just a friendly looking success header. This is here to make the page look legitimate and finished. So nothing about it feels like something's wrong to whoever's watching the screen. Let's follow this up with just code, ending the paragraph. And this is just a label that just announces the following text is the code. It's just a tiny detail, but it tells you the intent here is not accidental. The page is designed to present the code as a piece of info for the person to read and use. All right, now let's introduce the actual leak, which is going to be putting in a text area. And let's also close it off, of course. We love that. And we're going to be adding the raw code variable here. So just like that. And I'm interpolating the raw code variable, the same auth code that's supposed to be single use, short-lived, consumed automatically, and putting it directly in a text area. And a text area, simply put, is a UI element built for selecting and copying text. So what this line here is doing is it takes a credential that was never meant to be visible, and puts it into one HTML element that's optimized for a human to copy it out. Ooh. All right. Well, let's just open a new paragraph to wrap the link below. No security relevance on its own, but we're just going to be building a whole mini page around this code, which reinforces to the viewer that this is meant to be here. All right, let's introduce a second exposure. This is what it's going to be. Let's do href equals, and then add the rule redirect URI with the code parameter and the state parameter. State equals encapsulated state. I believe there should be a $sign there. Let's end that off like that. And this is just a plain anchor tag where the href is the exact URL that the server should have redirected to automatically. Redirect URI with the code and the state appended to it. So the difference here is critical, where a redirect is something the browser does for you, which is tied to that one request, whereas a static, just a href is just a string of text. It works identically no matter who clicks on it from any browser at any later time. So I've basically just turned a one-shot browser-bound handoff into a portable, reusable link. Yes, reusable. All right, let's continue. Literally. Just worded to look like a normal continuous step in a legitimate flow, not something users should be suspicious of. And of course, let's close off the tags that we had above, the /a and the /p, I believe. All right, and this is closed up. I think we need a semicolon. Yep. All right, so closing the template literal and the res send call. Summarizing what just happened here from what we had before here is, instead of a silent redirect URI, the server now stops and renders the code twice, once as a copyable text, once as a static reusable URL. And then they give both to whoever is looking at the screen, which is what the attacker is going to take advantage of. And notice what this code does not do anywhere, which is it never checks that state matches something the server issued and tied to this specific session before the flow started. So it echoes back whatever state was passed in. And that gap is what our phishing page is going to exploit specifically. But the reason it's exploitable this way with a simple copy paste instead of some network level attack is entirely because of what we just typed. Let's go build the delivery mechanism. All right. Let's just make a cheeky little folder. Let's just make it attacker tools, and let us add a new file, which is going to be CSRF hack or CSRF fish, CSRF fish, and it's going to be a HTML. Just because I want to style it a little. So before writing any HTML, this file is going to be in this separate folder, just completely outside of the actual client and the server code base. Deliberately, because in a real attack, this page has nothing to do with the legitimate app source because it's hosted independently and sent through a victim through email, chat, fake ad, victim's browser. It just needs to load at once. So let's build the base version and then iterate, add some social engineering, maybe add a tiny bit of decoration so it's not just plain text to make it slightly more realistic. All right, let's go from scratch. Well, let's just do the standard boilerplate. Just gonna be doc type. Thank you for filling that in VS Code, and then of course HTML, language English. Nothing attacker specific, just a valid HTML document. All right, and let's do that. Let's introduce the body, and I'm just staying bare bones without any styling yet. Just to get the mechanism working first, just to get the initial mechanism. All right, let's introduce the bait itself, which is going to be a single button styled link. And I'm going to have the ID just be re-login. And the href, let's just do a blank and that with a re-authorize now. Exclamation mark. And yeah, href being the waffle is what I love to call it, means that the link doesn't actually navigate anywhere on its own. It's a dead link. And the ID, relog in here, I'm just giving it an ID specifically so I can attach real behavior to it with JavaScript in a moment. And this is just a visible label, which is reauthorize now. Worded to sound like, just routine account maintenance. So just to, keep the victim unsuspecting. All right. Let's open the script block. This is where the attacker logic is going to be. And everything above this line is just going to be presentation, like visual presentation. All right, I'm just going to grab, okay, let's do document get the element by ID, thank you. And relogin, just the same with the ID above, with adding an event listener, being the click and event. Let's do event map to. Let's leave it like that for now. That. All right, cool. So yeah, what we're doing is I'm grabbing the button by the ID we just set and attaching a click handler here. And the moment the victim clicks reauthorize now as a button, this function is going to run. All right, so let's fill in the function. Let's add the event prevent default, closing that off, which basically is linking back to href being the hash sign. Since the href was just hash, this isn't really required. This technically isn't required, but it's good practice and it makes explicit that we are fully overriding default link behaviors with our own navigation logic. All right, continuing. Let's make a constant called attacker code. I'm just being prompt, and then this is just going to be paste attacker auth code. This is just for, I think I'll update this later, but for now, I'm just making the bare bones version. I'm just using a simple prompt function so I can manually paste in whatever code I've obtained from the browser and rerun this test with different codes without editing the file every single time, just for testing, just in case it doesn't work the first time. Yeah, this is just a testing convenience. In the final version, I am going to replace this with a hard-coded value that we switched because a real victim would obviously never see or interact with this prompt. Like, a victim isn't going to click a link and then see that it says paste attacker auth code and actually, be able to know what to do with it and do anything with it. It's not ideal. So yeah, we're just testing to see if the script works. All right, continued with an if statement. Let's do if it's not the attacker code. Let's just return, of course. Just a basic guard. If the prompt was cancelled empty, we just stop rather than sending a broken request. All right, let's follow that up with a callback URL. And that's just going to be the HTTP server of my local host running for demonstration purposes. I realize that I can't actually host it on Vercel or like whatever, because it actually like I can actually get like banned or something, and apparently there's a whole lot of danger that I can introduce to myself. Anyways, continuing, this is basically similar to the capture the flag from week 3 of 6841, where we are basically putting the encoded URL in here as a clickable link. I don't believe that should be that. So that's gonna have the attacker code, and with that, and have the state be just fish123, and let's end it with a backslash semicolon. This meant to be a backslash. Oops. There we go. Yeah, no wonder why it wasn't lighting up. Well, this is the actual forge request being built. This is gonna be the client's real callback endpoint, which is the same one a legitimate login would hit. I'm just attaching the attacker's code URL encoded, so any special characters in the code don't just break the query and accidentally. And a state value of just fish123. This is just completely made up. It can really be anything. I didn't get it from anything. The client never issued it for this browser. That's just fine, because as we saw in authorize.js, nothing is going to check it. And of course, let's put in the actual CSRF of window location, href, being the callback URL. And I'm forcing the victim's own browser to navigate to this URL. And the request that hits the client server comes from the victim's browser with the victim's cookies and network context. But the content of that request and the auth code is entirely mine. All right, let's end it off with semicolon here. We have the script, body HTML. I believe this is really terribly formatted. We'll just do that. Yeah, all right. Closing everything out. At this point, the mechanism, there's no squiggly lines, but yeah, it looks nothing like a convincing phishing attack yet. It's just a plain link on a white page. So let's fix that. But before we fix that, let's actually run what we're trying to do. So what we're trying to do here, let's just go into a random guest account. Oh my goodness. A test hack. Cool. And let's actually run our servers. Let's run our servers. Let's make 2 terminals here, because I do want to test out if this works. Let's split terminal, and let's go into auth server and the src. But for this one, we'll go into the client app, and then src. And let's just do node server.js, running the server, and node server.js. And let's open this in browser, see what we get. This is what the code looks like. Of course, visuals all done by Claude, and the logic done by Claude. Of course, I fed in exactly what I want it to make. And yeah, this is the website, which now has a vulnerability in it. Of course, we can't open the dashboard. This is what it looks like. This is basically a uni task tracker that tracks what uni tasks you have, and you can add and remove stuff. And it's a third party to the UNSW, or not actual UNSW, but just the university portal. So if we connect University Central Hub, then it takes us to the UNSW student portal for demonstration purposes. This is not the actual UNSW student portal. I just named it like that. UNSW, don't see me, this is fake. Just for demo purposes, I left the usernames and password up here. In reality, these would not be up here, of course. But let's log in as the attacker, which is going to be Alice and attacker123. And it's going to process secure access. Let's not save it to our browser. And let's approve the third-party authorization. And authorization is successful. And we get this code here that we're just going to copy. And we're not going to continue because we don't want it to use it up. For reference, it takes us to this token code page, because usually it would show up in the browser or in the console or in the network, but so that we have consistent demonstration purposes and I don't, copy it and close a window too slowly in time, for reference sake, I just added an auth code area. So we're going to copy this code. We're not going to continue so it doesn't use up the code. And let's close that. And let's open a new tab that's also going to have this localhost. And this time, it's going to be Bob who is going to be logging in. And Bob is the victim. This is just a random user, any user of this third-party app. And it's just going to exchange the code for a bearer token. And Bob is officially logged in. They have some private notes, comp 1511 assignment, buy groceries, and they can add some new private notes. Hi, I'm Bob. Hello world. Right, let's add that note. And now we are going to test a CSRF phishing link. Let's just reveal in File Explorer. Let's open it. And if we click reauthorize now, we're going to paste the attacker code we got from Alice before it got used up. And it's exchanging it. And welcome back, Alice, is what we get. And now I believe, Let's try that one more time. It's meant to be opening on the same tab as Bob's account. So right now, Bob's logged into Bob's account, and let's just input the attacker code again. We'll try that really quickly again. All right, I should have done this a bit easier, but yeah, let's just log into Alice's account again. Right? Alice attacker 123. Right? Approve, and we get Alice's account auth code. We're not going to continue, we're going to exit before it uses it up. And we're going to reopen on Bob's tab, because Bob is the one that's going to be clicking on this malicious link. If it doesn't make sense now, I'll change the code to make this a more obvious demo. And once Bob clicks on this malicious link, it'll automatically use up this auth code that Alice set up. And Bob is going to be logged in as Alice. And just for research purposes, I added welcome back Alice. Obviously, if Bob were to see this, Bob would be like, wait, Alice, I'm not Alice, and then log out, and then boom, you can't do anything. So just for demonstration purposes, I added this welcome back to see whose account it is right now. But in a real life setting, let's say an actual UNSW portal, it never says welcome back with your name in it. It's just the same portal that looks the same for everybody, which is why it's so dangerous. Because if you're logged into an attacker's account and you say make purchases or make private notes, then the attacker gets that stored into their account. So now you just gave the attacker your info because you didn't know you were in the attacker's account after you clicked on a suspicious link. All right, so I'm really glad to see it work. Let's just open these separate tabs to be, let's make this Alice and let's make that Bob, because Alice is the incognito one for future refs. All right, so this code actually works, which is great. We're just gonna build upon it by adding the social engineering part, because that demo just now was very unconvincing. Why? Because it had a link. If you click on it, you have to put in the Alice's ID. Obviously, Bob will never have access to Alice's token because Bob is a victim here. He doesn't know what's going on. So we're gonna make this a little bit more realistic. Let's below body. Let's just send to some divs. No, we're just gonna be doing some fancy shenanigans. Not really, just making a very simply styled place. Let's make the header action required university account details updated. And now this is going to be a little phishing. And let's make the text underneath. Dear students. And then follow that up with. We have noticed, let's do detected highly unusual activity on your uni task tracker account. To keep your session secure, please reauthorize the application by clicking the button below. So, okay, let's end that. Cool. So, line by line, of course, this is just a wrapper. I'll style in a moment to look like a card on official notice. The heading action required borrows a tone of like a real IT security email, like GitHub Guardian, for example, which is specific because it's, uni account details and dear student. Almost spear phishing. The dear student, addressing it to the student without needing the victim's name. And the body paragraph just does a classic phishing move, claiming unusual activity, framing the clicking of the link as a protective action instead of a risky one. So, nothing to be suspicious of. yeah, before I fully close off this div, the reauthorize button from before now should sit inside that container. Because the call to action at the end of this, because like it is the call to action at the end of this notice. So yeah, this should just be actually chilling in there before we close off the div. And yeah, reauthorize now, blah, 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 reauthorize now. Cool. Right? This looks about right. Yeah, that looks about right. Okay. Let's move on. Let's add some style now. Let's go above the body and let's add yeah, header. And we will just do some standard head metadata with the character set, UTF-8, with the meta name, just character encoding, and then a responsive viewport meta tag is what I want to be adding with viewports content just being the width of the device width. This is just, you know, initial scale, let's just do 1. Cool. And the title, just make a title of the browser, reauthorize. Right. Yep, this is just standard head metadata, character encoding, responsive viewpoint meta tag, so that this renders correctly on like device, mobile, since plenty of students will open a link like this on their phone. And the title reauthorize matches the kind of low-key routine tone we want the browser tab to have at this stage. All right, so let's move on to style. Yeah, all right. Let's add this below. Let's add a style section. And let's make a simple style from my to-do list project that I believe I made a while ago. Let's just do font, family, sans serif, default, with background being just, I'm not sure what I want to make the background. We'll just do that for now. We can change the colors later. Color. Oh. The color hex, and then yeah. I was hoping that this popped up so I can just drag it around. The margin being 0, and let's just do padding 0. See how that looks. Yeah, so this is just styling the body, just sans serif. Let's just do the background as like a dark red to signal like urgency. And yeah, just black is fine. Zeroing out margin and padding gives us like the full bleed background with no default browser tabs. We can actually check what this looks like for now, so that it doesn't look too terrible. Oh wow, okay, that looks pretty terrible, but we'll add some like we'll add some section so that it doesn't look this bad. But again, the red background already signals like urgency and scare if I were to exaggerate it. Let's also be adding a container now to trap the text. I'm just gonna do like a white container. Let's see if I remember how to do this. Let's just do max with like 1000 px. I'll probably refine this a little bit later, but I'm not, you know, too concerned. Just 4 margin. It could be 2. Padding just 4 as well, same as margin. And let's just make the background fully white, which would just be F. Fs. Yeah. Cool. Okay, so yeah, the container gets a white background, so it pops up against a red, and it should actually update. Perfect. All right, so we have like a simple card box here thingy. Cool. And yeah, just margin, just generous padding. First pass, we'll just keep it wide. No shadow, no rounded corners, just having that. And then we'll add, of course, the button style. Let's just do inline flex. With padding just being it's just 1. So what do we do? The background. I mean, I think the button should just be like green, I guess. I'll just change that to green soon. Let me just, yeah, sure. Cool. Background. Yeah, let's just do a green, nice and green button color. See how that looks. Cool. So now our reauthorize button is green. I just want to make it slightly lighter green. I love OCD kicking in. You could say OCD. There we go. It's better. It's better. It's not the best, it's better. Right, cool. So this is a working fish already, but we're just tidying it up to make it more convincing. Yeah, a few changes to make this land harder. I'm just gonna update the, let's see, title, tighten the card a bit, add some visual weight to make it feel like an urgent official model instead of a plain web page, and then we'll remove this button and make it into something hard-coded that, doesn't, yeah, make the poor victim have to put in the attacker code, because that is not like real life. So let's see here. I think we should just make the width a little bit smaller. Let's just do like add 10 there. Slightly less padding. Boom. Yep, more centered. Cool. Yeah, background. Let's even just add a box shadow to be fancy with it. Let's just do that. What do we make the color? We'll just do 0.000 and then 0.5 there. That should look a little bit better. Yep, now we have a little box shadow, I'm definitely not carrying away. Let's just update the button a little bit, but let's add a margin, top margin. Just do that. Padding is fine, I think. Yeah, okay, that is a little bit better. Let's add a border radius. I think I want to kind of make it circular, but not like just a standard button. All right, and let's just add the font weights too. Why not? All right, boom. And now it's bold, it's underlined, and it actually has more of a button shape in a card that's more phrase. So this is just like the phishing part of it and the convincing part of it, just so that, it's actually simulating something that looks realistic. And yeah, it just like, I do too much UX UI design. I care about these things. Big button signals action, makes user click on it, but they're doomed as soon as they click on it, is what I want to make it. All right, last change promise. Right now, the script uses prompt to ask for the code manually, which was useful while I'm testing, like I said, but in a real phishing page, obviously can't pop up a prompt asking the victim to paste in the auth code themselves, so I'm going to replace this with the hard-coded constant. All right, let us replace the script part here. You know what? Let's copy let's just copy these lines, I think. Okay, let's call back, yeah, okay, let's copy these two lines and then just redo this part. Actually, do we? I mean, I want to do something like, yeah, just have the attacker auth code be equal to just paste hackers auth code here for demonstration. And yeah, this is where I'm going to actually paste the real code just in this constant block, and then pass this constant block into the callback URL. Let's see how I can do it. we can keep this event listener. Yep. Except that we're gonna remove this and we're gonna remove that so that we don't have to manually put it in the page. And then the callback URL is just gonna be localhost encode URIs, and instead of the attacker code from before, we're gonna replace this with the attacker auth code, which is a constant from above, and the state doesn't really matter. And yeah, that looks about right, doesn't it? All right, let's see if this works. Let's do that. Oh. And this time, yeah, we will have to basically hard code it in for it to work. Cool. So it's functionally identical to before. The main change is just referencing our hard code so that the attacker can, hard code it instead of manual input. So that's a phishing page finished. Let's actually go get a real auth code and run this from the start for real. All right. Let's do this. Incognito is the attacker, Alice, and Bob. Like this is Alice's mobile phone or computer. This is Alice's computer, and this is Bob's computer. All right. They can't see each other's screens. Just treat them as separate devices for demo purposes. I really should have thought this through harder, although I did already spend like several days just figuring out how to set up the code and everything and thinking about it. But all right, let's run the servers, node server.js on the client app and the auth app. Let's go into the client app front end. This is Alice. And this is going to be Bob. They're going to both be connecting to the individual logins. Alice is going to log into attack. And while that's doing, Bob is going to log into his account. And they're going to approve the third-party authentication of Uni task to the UNSW. And authorization successful before usually it would pop up in the link really quickly and you'd have to copy it and then close it really quickly. But I found that to be really inconsistent. So that's why, again, I added this part. And yeah, Bob is just going to see that and Alice is going to see this. But before it uses up the auth code token, Alice is going to swiftly close the tab. And now she has an auth code for the third party. Cool. All right. Now, let us paste in that hacker's auth code here. Boom. We pasted it in. Now what? Well, let's go to Bob. And let's say that Alice sends Bob a nice little gmail.com. Bob opens it. He opens it. And it's like some Gmail that reads, drum roll please. Bob opens his Gmail. And Alice has just sent him. Boom. Action required. University account details updated. Dear student, we have detected highly unusual activity on your Uni Task Tracker account. So to keep your session secure, please reauthorize our application by clicking the button below. Let's just make sure this is saved. But this secret button is this whole piece of code that Alice has cooked up with her authorization code to her account. So Bob clicks on this link. Mind you, Bob is on his account. And this is just demonstration purposes to see whose account it's on. Bob's going to click this link. Oh my god. We have to reauthorize. My account's compromised. Whew. It worked. Thank God. I can continue doing my stuff now. But little does Bob know, he's actually now in Alice's account. Oh, so now he's in Alice's account. And let's say that, again, these aren't going to show. Let's say that Bob makes a little transaction and he has to put in his card ID. Let's just make a fake credit card. And Bob makes that. And then the 3-letter CVC. And then the expiry dates, 29. And then the full name, Bob. Let's just do Fisher, just as a little meme. and Bob makes a payment. Boom. Bob just thinks he just made a payment on his account and he goes to sleep. Oh, phew. Hey, my account's back. I'm just gonna, because I'm Bob, I'm just gonna make this quick payment and then I'm gonna go sleep. Now Bob thinks everything's good and Bob is sound asleep. Let's see what Alice is up to. Alice is gonna wait a few hours and then log into her account, which Bob was just on unknowingly. Alice is gonna log back in after a few hours of sending that link, hoping that he clicked on it, and Bob thankfully clicked on it. So when Alice logs into her account now, let's see what she can see. Voila! Alice, because Bob was on her account and made a purchase without realizing that he was now on Alice's account because of the redirect, because of the auth code redirect, Alice now has access after logging in to Bob's credit card here. Oh. And of course, Alice can do terrible, terrible things with this credit card. So that is a successful demo done. And let's actually just quickly talk about what actually went wrong and how, again, do we fix it? The two safeguards failed here. First of all, authorize.js handed out a code in a form that a human could copy and reuse outside of the original browser context. And that's what made this simple copy-paste attack, instead of something requiring network-level interception at the minimum. And second, and more fundamentally, the client's callback handler never verified that the request received corresponded to a flow it had actually started. And the fix is just a straight revert. Line 383 goes straight up back to, and I'm so glad I commented this out now, because I might have forgotten this code, or messed up a little question mark here. It's going to go back to this, the return res redirect. Let's actually comment out the hacker code here and comment back in the real code. And yeah, this uses a redirect, of course. And the lesson here, of course, is never render an auth code into a page body, a text area, or a static link even. It should only ever travel inside one automatic redirect, according to 6749. And the second more important fix belongs to the client, where before redirecting to authorize, generating a cryptographically random state value and storing it server-side, tying it to the user session, for example, in a signed like HTTP only cookie, as one example. And then on callback, just require the return state to match the stored value, reject the request, and then treat auth codes as single use, short-lived, etc. So even a leaked code has only a tiny radius that it's alive. And when possible, adding PKC RFC 7636, which is binding the code to a code verifier, only the legitimate client instant holds, which closes this class of attack even harder. But that is a bit out of the scope of what I'm trying to do here, and poor me has exhausted Claude's tokens to generate the rest of this. So yeah, state isn't optional though in the OAuth 2.0 implementation. It's genuinely the only thing tying a callback back to the request the client actually made. So not implementing state, just simply not implementing this one line code in your authorize for 2.0 makes any valid code from anywhere become an all access pass, which shows how dangerous it is to not implement this. And you need to specifically know what you're doing when you're implementing it. And yeah, this is of course a fixed version. Now that we have fixed it again, I would just demonstrate that this does not work anymore with a quick demonstration. One last demonstration of the correct implementation now, right? Let's just reset the servers. Let's refresh the page back to the start. And if we log back in Alice and Bob, Alice, even with the full code, should not be able to log in with it. Let's see what happens with this secure demonstration. Right, both of them are going to approve the third party to get a token that exchanges a token for a bearer token. And of course, again, there's no link it appears at, and even if they got, like Alice found, oh, right, this callback link, which is in the link here, yeah, this is what I meant. It's in here right now, callback code right in here, right? So yeah, again, just reiterating, the reason why I added like the auth code like copyable thing before you exchanged it was because the other way to do it is approving it, and then a hacker looks at this or console, and then they need to copy this code and then exit out, which obviously is very doable, but for the consistency, it doesn't work. So if we quickly do that before it exchanges to copy the code, which is this, and paste it into the phishing code. And of course, Bob wants to sign in first. And Bob is in, and then Alice again tries to send out this phishing Gmail. But of course, this time the 2.0 is set correctly. So if you reauthorize, even as Bob sees this, Bob is like, oh no, I need to reauthorize. All you get is a sign-in issue because the code is invalid. It invalidates the code, or already has been used, but in this case, we exited out before it exchanged the token, which is why it did not get used. It just invalidated the code. All right, so that concludes the demo of a risky or wrong implementation, which is simply forgetting the state parameter or the state checking, the state field I meant, and skipping it, which results in devastation of the CSRF attack. And I'm gonna leave up this this vulnerability for an in-person demonstration for 684 in week 8 or 9 to 10, 8 to 9, whichever one it is. And I'm just gonna quickly push it to my GitHub before I forget. So auth code, paste Alice auth code here, and let's now add it. Git status, git. Let's add all that. Git commit. Demo, let's just keep it simple. Implementation of CSRF attack and vulnerability introduction. And let's just push it to the attacker branch. Yep. And that's that. That concludes a CSRF phishing attack with the introduced vulnerability. Cool. Thank you.